This lesson is about completing the square. It's an algebraic method that I'm going to teach you. What we're going to do this year in pre-calculus is, this is your standard form of the quadratic. Y equals ax squared plus bx plus c. And this form of the quadratic tells us if the parabola opens up and downwards. The squared tells us that we're going to have more than one root if we set this equal to 0. The c tells us where it crosses the y axis. What we're going to do is actually change this to the vertex form. So this is the standard form of the quadratic, and we're going to switch to the vertex form so that we are going to find out different information. So if we switch to the vertex form, which is y equals ax minus h squared plus k, now we can figure out what the vertex of this parabola is algebraically and the axis of symmetry algebraically. By doing this, you can get more information. Now, I know you guys can graph this. I know you can check it, but this is the algebraic way to do this. So let's kind of start out first is, what is completing the square? Well, basically, we're forcing the existence of a perfect square trinomial What is that, you ask? Well, this is what completing the square is. It's not exactly the square that you think of. It's more like this: a plus b squared. This is what we want. And if I were to multiply that out, it'd be a squared plus 2ab plus b squared. So we're going to take some information that we have, a formula, and we're going to go through and we're going to make this happen. We're going to force it to happen. Why are we doing this? Well, again, I'll just tell you why. You can actually, the first thing that we did last year is we actually put the standard form equal to 0. This is what we did last year in Algebra 2 Trig. And then you guys were able to solve for the roots or the zeros. In this course, I don't focus on completing the square for this reason. I'm going to let you use the quadratic formula or factor. That's good enough. So basically here we're going to actually rewrite our equations into vertex forms. Okay, now first of all, I'm going to go through and do the steps. The steps aren't going to mean anything to you until we actually practice some, but it's nice to have the steps done. The first one is we're going to factor out the coefficient in front of the x squared term. We only have to do this if it's not 1. Okay? The second step we're going to do, this is where we're actually forcing it. So that right here's the step that we're forcing it. You're going to make the parentheses with a little squared, and you're going to put an x here, or whatever the variable is, plus you're going to do half of the middle term. So that's what that means, half of the middle term. Now, when you force it into this form, you've actually added a value there that, even though you can't see that, if you multiplied it out, you would see the value. So you have to subtract the value you added by doing that term. And you'll see what that means in a little bit. Okay? What you really do is you square the second term in the parentheses right here. You're going to square it and subtract because you want to get rid of what you had. All right. The fourth thing is we're going to combine like terms. And then the fifth step is we're going to distribute the coefficients, so you're done with your new formula. Distribute, the coefficient. Alright, let's practice a few. Now, before we actually do what's in the notes, and I know you might not have room exactly where you are, but to find a spot, I want to do a couple of these basic ones so you can see why we're doing this, because I'm a little concerned. I just don't want to show you this and then you don't understand what we're doing. So if you have room here, I'm going to do it here at the bottom. So let's just do a couple practice rounds before we start with the actual problems. So if I had this parabola, y equals x squared plus 6x, okay? Now, this is in standard form. I know it's a happy face parabola. This is my middle term, and my c is 0, so I know it crosses on the origin. If I want to force this to do a perfect square trinomial, this is what you do. First of all, I check. In front of the x squared term, there's a 1, so we're good. We don't have to factor anything out. So then the second step says we're going to start completing the square. So we're going to make this parentheses with a square term. This is what's in the first part of the parentheses, so you just write the x down, like I said, and then you do half of the middle, keeping the sign the same. Okay? Now, when we do this, I've basically completed the square, but you can't change the value. It's x squared plus 6x, and this right here is x plus 3 squared. Well, this has to be the same as this. It can't be different. And if you were to do x plus 3 squared over here on the side, and don't write this down, but watch what I'm going to do, because I'm going to do another one. If I actually multiply that out, wouldn't I have x squared plus 6x plus 9? So this matches okay. But now I have a 9 in there. See how it's in there? You can't see it, but it's in there. We have a 9. So what I have to do is take away the 9, so now this actually matches this. It looks different, but if I were to multiply this all out, I would get this, and then if I take away the 9, see how this goes away? So now I end up with that. So I've actually changed how it looks, and I've completed the square. Now this is in vertex form. Now if I look at this right here, I want to know my vertex. Well, the vertex of my formula is always hk. Well, here's my h, here's my k, and you always got to change the sign in the parentheses. So my vertex, or my turning point, is -3, -9. You keep the sign here. You just change the one on the inside. My axis of symmetry, which I'm going to let you shortcut as we get going, but the axis of symmetry is always, this turning point is on the x equals -3 line. So that's my axis of symmetry. Okay, let's try another one. All right, let's do number 2 right here. All right, what if I had y equals x squared minus 10x? Now I picked this one. This had a plus, this had a minus. Well, I want to change it. I want to complete the square. So I'm going to say y equals, there's just a 1 there, so we're just going to do a parentheses, squared. You write the x term down, keeping the sign half of the middle. Now, if I were to multiply this out, I'd have x squared minus 10x plus 25. So there's a plus 25 in there, and if you'll notice, if I squared this and subtracted it, then that would get rid of it. So if I multiply this all out, I'd have x squared minus 10x plus 25, and then I take the 25 away. Now I'm back to this. And the other thing I wanted to show you, it doesn't matter what the sign is in the parentheses. You still have to subtract what you added, because when you square this second term, whether it was this problem or this one, it always turns positive, so you always subtract. So here the vertex of this one is going to be 5, -25. The axis of symmetry, which I'll let you write as AOS, is x equals 5. You have to write it like that. Okay? Now, we're going to try some harder ones, but I just wanted to kind of get a warm-up of what we're going to be doing. Okay? So let's start with these right here, and some of these are going to be harder than others, and you're going to have fractions, but don't let it bug you, because you have a graphing calculator. You can always do this. So we're going to take this one here. Right here we have f of x equals x squared plus 3x minus 7. Alright, now I want to complete the square so I can get it in vertex form. So I'm going to write f of x equals, I look in the front, there's a 1, so I don't have to factor anything out. So I can go immediately into completing the square. So I put my parentheses there with a square. Here's an x squared, so I have an x plus half the middle, and the middle is a 3, a positive 3. I do not want you to write it as 1.5. I want you to write it as 3 halves. When you divide something by 2, or half, multiply it by half, all you do is put a 2 in the denominator, and that's half of what you started out with. Alright? Now, here I have a negative 7. Well, that's fine, but right now I'm just looking at this part of this. This negative 7 I'm going to bring down later. And look at, okay, I've got x plus 3 halves squared. And I have added something that was there. Well, if I multiplied this out, I would notice if I squared this second one. So if I square the second one, I have 9 over 4. I have to take away 9/4 and bring down the negative 7. Now, if you're a little concerned how I got the 9/4, let's do it up here. If I had x plus 3 halves squared, I would write it like this. Okay? And if I squared that, I would have x squared, and I'd have 3 halves plus 3 halves, which is 6 halves x, which is a 3x, and then now plus a 9/4. So this is okay, because now this matches this, but now I have 9/4 left, so I had to subtract it and then bring down the negative 7 so it matched. Now you can't really leave it like this. You should combine these terms. So I'm going to do f of x equals x plus 3 halves squared, and then when I combine these two, now this is over 4 if I wanted to have a common denominator, so this is really negative 28 over 4 minus 9 over 4, or you can put this in your calculator, it doesn't matter. These will come out to be negative 37 over 4. And that kind of bugs people because you have all these fractions, but you know, not all your parabolas are nice, neat numbers. So the vertex of this one, or the turning point, is going to be negative 3 halves, comma, negative 37 over 4. And the axis of symmetry is always x equals whatever your x value is, negative 3 halves. Now, you can graph this on your calculator and look at the vertex to make sure that you did it right. But you have to show all the algebra on this. I want to see every single step so that I can see that you know how to complete the square. Alright, let's try another one. This one, we have an actual coefficient here, so we're going to have an extra step. So the first step is we have to just factor out the 4 so that the x squared has a 1 in front of it. So I'm just going to take the 4 out, so I have x squared plus. Now there's a 1 here. If I want to take out a 4, we're really dividing by 4, that's 1/4 x, and then 2 divided by 4 is 1/2. And if you don't believe me, go through and distribute it back and you will see that you'll get that. So I've taken out that 4. Now what I'm going to do is that 4 is going to hang out while we complete the square. So I want you to do a bracket here, and we're actually going to complete the square right here. Okay, so I put my x down and half of the middle. Now if it's a half of 1/4, all you need to do is double your denominator or multiply it by 2, or however you want to think it. It's going to be x plus 1/8 squared. Now I have to take away what I added, which is going to be 1 over 64, which is the square of the top and bottom, and you always subtract it, and then bring down my 1/2 and then close the bracket. Now before we do anything with that 4, we're going to leave the 4 hanging out while we finish up in here combining our like terms. So I'm going to write like this, and then I'm going to combine these two right here. You can put it right in your calculator if you'd like. Or I know that this is the same as 32 over 64 minus 1 over 64, so that's going to be plus 31 over 64. So I've got that part done. Now the last part, this is the tricky part, you have to distribute this. So this part's easy. Everybody kind of remembers, alright, yeah, it's going to be x plus 1/8 squared. But now when I multiply this by 4, and you can multiply this in your calculator if you'd like, but you can do 31 over 64 times 4, you're going to end up with plus 31 over 16. Please don't forget the second distributive. Now we're done. Now I can do my vertex. My vertex is going to be negative 1/8, comma, 31 over 16. My axis of symmetry is going to be x equals negative 1/8. Alright, let's practice a couple more. Alright, we got 2 of them here, and after these 2 I'm going to stop. I just want to make sure that you had practice. So we're going to rewrite this, and I look at the coefficient in the front and I see it's a negative 1. So I've got to factor out that negative 1. So I have x squared, and when I factor out negative 1, it switches all my signs. Now the negative 1's going to hang out while we complete the square, and then we're going to multiply that back through when we're done. So I've got x minus a half of the second, which is a 1, so it's going to be minus a half squared. What did I add there that was not there before? It was a 1/4, so I'm taking it away and bringing down the 6. See? X, half of the middle, take away what I added, which is this squared, and then bring down the 6. So now f of x is going to be, let the negative 1 hang out while we finish. So we get x minus a half squared. Now when I combine these over 4, this will be 624 over 4 minus 1 over 4, so that's 23 over 4, and it's going to be a positive 1, or you can put it in your calculator. Now I have to distribute through with the negative. So I have f of x equals negative x minus a half squared minus 23 over 4. Now, oops, sorry, we're done. Now I just know this is a sad face parabola. It's a parabola that opens downwards. Now let's do the vertex. And the turning point or vertex of this parabola is 1/2 comma negative 23/4. And the axis of symmetry is going to be x equals 1/2. Okay, last one I'm doing on this video, even though we're going to practice more in class. I want to complete the square on this one, so we have to get rid of that 12. So I have x squared plus 8 divided by 12 is 2/3 x plus 5 divided by 12. Now, the 12 is going to hang out while we complete the square. So I put the x down and half the middle. So you double the bottom, so it's going to be 6. 2 6 is 1/3, or half the middle. Take away what we added. We added 1/9, so I'm going to take it away. Top and bottom squared. And then I'm bringing down the 5/12. So now I have 12 parentheses x plus 1/3 squared. Then when I combine these two with a common denominator, or you can put them in your calculator, doesn't matter, you end up with 11 over 36. So now I have 12, and I can distribute through now. X plus 1/3 squared plus, now 12 times 11 over 36 comes out to be 11/3. Now there's my vertex formula. So my vertex, now it's in that method, is going to be negative 1/3, 11/3, and my axis of symmetry is x equals negative 1/3. And we're going to complete some more in class, but that'll kind of get you started so that you'll have seen it before we do it in class.